Okay. All right, guys. So what do you see on my screen?
Application load balancer.
Okay, good. That's where I want us to be. So the first thing we'll talk about today, really quick, just a high-level overview. Is one of the service that Amazon Web Services has that is a really highly used application, and that's application load balancer. Load balancer, they call it elastic load balancer. Again, when you see that word elastic in front of any of the services that we are talking about, which it just means that that service can grow. So it can grow based on your demand, based on your like what you want, based on like your preferences, the things that you want to do with your application. So it can shrink and then it can grow, which means you can reduce it or you can expand it. So load balancing automatically distributes your incoming traffic across multiple targets. So basically, that's the function of a load balancer. It sits in front of your application, and then it listens to the requests that are coming in, and then it takes those information and distributes them to the respective locations where they are to go. And that, I mean location, the server, the information is supposed to go to. So the load balancer, if they ask you for fault tolerance application, if they ask you in an interview to talk about one system or one software in a fault tolerance or highly available application, think about load balancing, auto scaling. So load balancing and auto scaling. So those two, you have to talk about them when you are talking about high availability, fault tolerance. So load balancing is one, because the load balancer, it can look at your traffic and it can detect when one application is out or when an application is having an issue, like health check issues, and then it can route that traffic to the other application. So it's just a software that manages like the incoming traffic in your application. So when I'm talking about traffic, it's like really how much like your application is being accessed. You know, if you have a website, how many people are going to your website? How many people are searching your website from the browser, from the internet? So you can use such as EC2 instances, container, IP address in one or more availability zones. So with load balancer, you can use multiple targets. So in a load balancer, you have something we call target groups. The target groups, we're going to talk about it down a little bit, but it's right down here. Target group is just a logical isolation of like resources that you want to attach to a load balancer. That can be easy to majority of the time for us. It's going to be easy tools. Yeah. Elastic load balancer, load balancing scale your load balancer as your incoming traffic changes over time. So again, I already explained that it detects like what kind of traffic are coming into this application. And so if it knows that, okay, every Wednesday, this is what is happening. So it can detect that and then make changes based on that algorithm. So it automatically scales to the vast majority of workload. So look at the workload, and then it can scale. Elastic load balancing supports the following load balancers. So we have application load balancer, which we are going to see shortly. This is what we are going to do the demo on. And then we have network load balancer, and then you have gateway load balancer, and then you have like this classic load balancer. So I don't think they support this classic load balancer. It's on the console anymore. We'll take a look at that. I think the only one that are there are those three: the application load balancer, the network load balancer, and then the AP gateway load balancer. You can select the type of load balancer that best suits your needs. So you can select for application load balancer. So both of the application load balancer, network load balancer, and gateway load balancer, there are specific situations or specific applications that you will need to either create an application load balancer or a network load balancer or a gateway. So your application and your project will determine that. Because in your application, in your things, you have what we call like deliverables. So those deliverables like requirements. That's why you do like requirement gathering. When we do talk about a little bit about project management, you hear we talk about like what are the deliverables, what are the project objectives, you know, what are the requirements. So before you do anything, you have to do requirement gathering. This is where you actually contact your clients, your customers, try to get information about them, especially those who let's say they want you to develop a website for them. So you got to do some requirement gathering. What are the functionality of your website? What kind of website do you want? Do you want an e-commerce website, or what kind of website do you want? Is it for advertisement? So these are all requirements gathering that you are getting. And based on that requirement gathering, you are going to determine whether you will need a load balancer or you are not, or what kind of load balancer you're going to need. So for application load balancer and components, it's a application load balancer service as the single point of contact for clients. So it serves as a single point of contact. So it's through that, like the client who contact your applications. The load balancer distributes incoming application traffic across multiple targets, such as EC2 instances in multiple availability zones. This increases the availability of your applications. You add one or more listeners to your load balancer. So the architecture of a load balancer, you have a target group, and then inside you also have something they call listener. So it has to have a listener. So the listener it contains like the protocols. So a listener can be like, you can say, okay, I want my load balancer to listen to all the traffic that are coming on port 80. And then you can also say, okay, I want my load balancer to listen to all the traffics that are coming from port 443, so you can configure a listener to do that for you. And then a listener checks. A listener checks for connection requests from clients using the protocol and port that you configure. So that's what I just explained that. So if you configure port 80, then the listener is going to listen to connection request. Anybody that wants to connect to that application through port 80. So the listener will listen to that. If you say 443, then the listener will listen to that as well. You have what they call the rules. The rules that you define for a listener determines how the load balancer route requests to each registered target. So inside a listener, you hear about something we call a rule. So a listener will have a rule. You can redirect traffic. You can say, hey, any traffic that comes to this application, I want you to redirect it to this. So let's say you have you say production, or let's say you have like orders table, customers tables. So you can put a load balancer, and inside that load balancer, you have a listener, and inside that listener, you have a rule that will state that any traffic that is coming that says /order, that traffic is going to be redirected to the order instance, the instance that have the orders application. Any instance, any traffic that is coming that says payment, you can redirect that to the appropriate server that deals with payments. So that's what the load balancer, the listener, everything, they work in combination to perform that task. So you have to configure that rule. It just doesn't do it just like that. So you have what we call target group. So the target group are the EC2 instances or the applications that you want the load balancer to target. So this diagram illustrates the basic components of a load balancer. So you have here the load balancer and you have the listener. And inside of this listener, you can have multiple listeners. You can have one or two listeners. So on the left here, you can see that we have listener one here, and inside that listener, it has a rule. And that listener has a target, has two targets here. You can see it has targets. Let's say this is target A and target B, and it has target group health check. There's a health check here. So if your instance is not configured well, you can see that this health check will fail and the load balancer will not work. So whatever target is in this, whatever things that you have targeted, EC2 instances that you have targeted, you have to make sure that they are in here and they are healthy. So this is two example. This is an example of two listeners. So you, the user, you sit right here in front, right here, and then once you make the request, let's say you say google.com, it's going to come to the load balancer, and the load balancer is going to look at, okay, I have these listeners, so google.com, where should I go? And then it will say, okay, there's a target group here that has this google.com application or here. So this is how it looks like. This architecture, it's only if you have two listeners up here. So usually it's just this one, but for high workloads, you have even more. You have more than it will be more complex. So application load balancer, it falls under it's an application load balancer function as the application layer. So remember, I talked to you guys about the OSI model, which is the Open System Interconnect. I talk about that, the OSI model. So the application layer, it falls under the application layer. The application load balancer fall under the application layer on the OSI model. So if you remember that, go back to the recording and watch that. And I talk about the different layers, the application layer, the presentation layer, and all those kind of stuff, the network, you know. So the data layer, and the other one. So if you've not watched those videos, or go back and watch those videos. The benefits of migrating from classic load balancer. Okay. So right now they are not doing classic load balancer. They migrated from classic load balancer. Yeah, so these are some of the reasons. I'm not going to go over them. You can go over this one. So these are all the related services that you can see. Amazon EC2, Amazon Auto Scaling, Certificate Manager. So we're going to see the Certificate Manager today. Amazon CloudWatch, Amazon ECS. So most of these things I want to talk to them. I want to talk about them today, actually, even if we don't do any demo on them, but just talk with them. We already talked about this one. We've not talked about WAF, Global Accelerator. Anyway, so that's a high level overview of what load balancing is. Anybody have any question about load balancing? Okay, so we're gonna move on. I'm gonna pull up my so the other thing that we're gonna come onto. So we're going to look at CloudFormation. So for this CloudFormation, I'm going to go over some slides really quick, just to explain stuff really quick. So you guys can see this the CloudFormation thing, right? I said CloudFormation 101. You can see that, right?
Yes.
Okay. So what is CloudFormation? So CloudFormation is you don't pay a zero cost AWS services for provisioning resources in a predictable, repeatable, and automated way. So one thing I really want you to take note of here is this automation. So basically, I've been talking to you guys about automation. So this is automations. For some of you who have been doing IT, or at least who have been doing this training, you should understand, you should know now what automation is. If you don't know, automation is just a process, a way of like reducing the manualized effort of like provisioning resources. When I talk about provisioning resources, it's basically just saying creating resources. So instead of like manually going to AWS, like the console, and create all those resources, we want to be able to do it in a seamless way, in a fast way. And then because the reason why we want to automate things is because when we do things manually, it's hard for you to replicate those manual effort, because the next time they ask you, some organization, if you are lucky, you get hired in a large company, they probably has thousands and thousands or hundreds of resources they need to create or that are created. So if they want to manage that, they are not going to be able to manage it if they are doing it manually, because it takes a lot of time to do stuff manually. But when you have a piece of code, and that code, all you need to do is to trigger that code or push that code, and then it can perform the task for you, it's much better. One, it's to reduce the cost, the overhead cost on like how much you are paying, how much people are taking time, how much time people are taking to provision resources. Reusability is another big example. You can reuse this, you can package that code and send it to another member of your team, and they can reuse that code again as if it's there. So there are a lot of like advantages. Many organizations, they are going for automation, and they are now heading towards automation. Many, if not most, if not all. Okay. So CloudFormation is AWS specific. So it's not, I'm going to use the word cloud agnostic. So it is not cloud agnostic. CloudFormation, it is not cloud agnostic. And what I mean by it's not cloud agnostic, it means is that it does not support other cloud providers. It is specifically for AWS. It specifically provides only resources within the AWS ecosystem. You cannot use CloudFormation to provision resources, at least at this time when I'm speaking. Maybe they are going to change it, but right now, you cannot use CloudFormation to provision resources in GCP, in Azure, in any and you cannot, you won't be able to do it. So it is not cloud agnostic. So that's one of the disadvantages. So here are the use cases of CloudFormation. How do you know what change and when they change? So you see that CloudFormation will help you answer this question. How do you know what has changed in your infrastructure, and when do those changes take place? CloudFormation, with code, you can tell when that happens. With manualized effort, it's hard for you to keep track of like who did what they do that, of course, CloudTray can help you with that. But yeah, and then you have infrastructure as code, version control. So how we call version control, which we'll talk about later during this class. Version control. How do you know like what version of the code or your application? When did they create that version? Know exactly what changes and when. Easy to integrate in deployment pipelines. Easy to replicate infrastructure. So that's what I explained earlier. You can replicate the infrastructure just because you have a piece of code. You can go to another region and just use that piece of that code, and then you can have the same infrastructure in one region to another region. Rule of the road: do not start with CloudFormation. So this is basically what you guys are doing. I could have just started everything with this entire class using CloudFormation, but that's not really a good thing, because if you don't know how to do it manually, how are you going to know how to automate it? You cannot just jump into automation. You have to know how the thing works first, how it operates on a surface level, on a bare bone. How does it work? And then once you know how the thing works, then you can start using CloudFormation. Is when I say infrastructure as code, automation, it's a way of like you already know how to do this stuff. But now you are getting too lazy because it's taking a lot of time to just go and click. If you want to create EC2, you just go and then do. You have to go create and look all of the load balance. That's a lot. If you know the stuff now, it's a lot. You don't want to, like for me right now, I don't want to spend a lot of time on that. And so CloudFormation will help to reduce that so that you don't have to do that click. You just do one single click with the code. So do not start with CloudFormation. Start on the console. Start creating resources on the console, just like what we've been doing. Understand what available options are there also. So it's not just CloudFormation. So in this course, I've shown you guys, if you guys have noticed, I've shown you guys multiple ways on how you can create a resource. We did auto scaling. Auto scaling created resources for us. We did Lambda. Lambda created and even deletes resources for us. We did CLI. The CLI, you can use a CLI to create resources. We've done all those things. Now we are talking about automation. So you got to know like what options are there. If you know that, okay, this is the CloudFormation is the only way, then that's the only way you are going to think that you are going to provision resources. And that's not really true. In fact, they have SDK, they have CDK, these are all things that you can use to provision resources. They have SAM, serverless application module. You have that one that you can also use to create like serverless applications. Do not reinvent the wheel. Do not start to scratch from scratch. Like I said, find a template online and start with it. That's what I do. I find a template online. Last night I stayed up till 2 o'clock because I'm just preparing myself for this class. And so I have to check online for a lot. And I was able to find things that I want, codes that I want, which we are going to talk about today. So do not reinvent the wheel. Do not start scratching your head. You can do that if you want. Over time, it makes you to be better and better. But then it's going to take a lot of time, right? Right now, we are living in a fast-paced world. CloudFormation Designer is a GUI. So we're going to look at what CloudFormation Designer is. Okay, I'm not going to spend much time on this. Template. So the template has different functions. So CloudFormation is written, it's a AWS infrastructure blueprint. So CloudFormation just see it as AWS infrastructure blueprint. It is written in 2 languages. You can either use one of these. You can either use JSON or YAML. JSON or YAML. JSON is JavaScript object notation. I explained that the last time. YAML, I forgot what YAML is. Let's see here. It doesn't matter. They are not going to ask you what is YAML. They are not going to ask you to give the meaning of this YAML. It's good to know if you can check if someone can check right now as we're on this call, what is YAML and tell us that. I forgot. If you can check what is YAML and tell us that would be really nice. But what you need to understand is it's written in JSON and YAML. So I'm gonna show you the difference. In fact, I'm gonna show you how you can convert a JSON document to a YAML document. So, and then stack. So in a template, you have stack. So you have stack, and then you have change set. And then, so in a stack is just a collection of resources that you want to manage, that you want CloudFormation to manage. So you put all the resources like EC2, all the resources, I mean like all resources. If you want to create like a 3-tier application wherein you are going to have let's say 2 EC2 instances for redundancy. You have like a load balancer, you have auto scaling, you have like security groups, you have VPC, of course you start with VPC. And so you have all these resources. How you group them together, that's what you call stack. So the collection of resources that are managed as a single unit, it's called a stack. Group resources that live the same life cycle in a single stack. So if you are creating resources, you put them in a stack. So we create the stack. The stack is what creates the resource for us. And then you have what is called change set. A change set is a dry run for updating an existing stack. Let's say you run a stack and later on you realize that, oh, I wasn't supposed to put that port 80. I want to make a change. So you can go back and make a change, but you make that changes to your code. And then instead of coming to start all over again, you can just do a change set. So a change set will update. It's not going to tear down what it has already have, but it's going to update. It's going to update it to the newest thing that you have. Just give me a minute. Okay, so yeah, so that's like change set. So if you want to update your application, then you want to do change set, unless if you want to rule out everything. It provide a list of actions that will be taken. So it will tell you like what is going to happen. So the update behavior of a stack is like this. You update with no interruption. You can choose to update with no interruption. You can choose to update with some interruption, or you can choose to replace the entire stack. If you say update with no interruption, so which means it's going to update your system, but it's not going to, the users are not going to be interrupted. The user activities are not going to be interrupted. If you say update with some interruption, which means they are going to experience either low latency, sometimes that will see like if they are working on the application, you see that it will spin, 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 but it's still working, but it's just spinning. And then you can choose to replace the entire stack. Untitled resource deletion. It said, be careful. This is just a caution. Be careful with certain resources. If a change is not allowed for a given parameter, CloudFormation will destroy the existing and create a new resources. There is one thing I want to mention really quick. So CloudFormation also it's a part of a language we call a declarative language. So CloudFormation, so you have what called declarative and imperative language, right? And with declarative language, you describe what your infrastructure should look like using a template. So that's what we talk about templates. So talk about templates, you have stack, and then you have change set. So a template is like what actually has your code, the code that is going to provision the resources for you. That's called a template. That is, you create a stack from a template. Without a template, there's no stack. So you got to remember that. Without a template, there's no stack. In fact, the template is actually the blueprint of that infrastructure, because it is from that template that you are going to define what resources that you are going to create and how you want to create them. How many, let's say you talk about storage. How many storage do you want? If you have 5 EC2 instances, how are you going to allocate that storage? That's all going to depend on how you define your resource definition. So that's declarative. So declarative, you state what you want, how your infrastructure should look like in your template. You specify the resources. You declare you specify the resources and their configurations. So if you're going to configure like let's say you want to add Apache, you want to add a website, something that can display on the browser. So those are all configuration. Let's say you want to install Docker, or let's say you want to install Kubernetes, or let's say you want to install something in that application. That is configuration. So you have to define that as well. And you have to define all dependencies, but not exactly, not in the exact sequence. CloudFormation will do the rest for you. So that's declarative. Imperative, you don't focus on decline. That you just say I want this, and then so when we look at so CloudFormation is declarative. We are going to look at another infrastructure, a big one that competes with CloudFormation. They call it Terraform. When we look at Terraform, then we'll look at what language Terraform is using. So we're not looking at Terraform right now. We're focusing on CloudFormation. But I just wanted for you to understand that. So this is just an example of like the CloudFormation. So we're going to see this in the demo. But so this is the format, the YAML. This is a YAML format. So the first that you see on a YAML format, you see this AWS TEMP late format version. So this is by default. This one has to be there, right? So this is there. This is just the version. It will tell you the version. So just put it like this when you are defining the template. So this one has to be at the top. Because if AWS make any changes, because AWS will update every application, even your iPhone or your cell phone that you use, they are making different versions. That's why when you update, probably update to a newer version, newer OS. So the same thing also, Terraform is updating. This is software. So Terraform is updating this software frequently. So you got to leave this there. You're always on your templates. If you look at any Terraform template, you will see this one. And then the next thing so this is the backbone. This is the backbone of Terraform. This is like the structure. So there's no code in here. We are just talking about this. So here the description. After this one, you see majority of the time you see description. So the description, you write it in a string form. Description are written in a string form. So let me show you guys really quick here. I told you guys about this website the last time. I don't know how many of you actually went there and take a look, but this is a website that's really good if you are learning, if you want to learn programming. I'll probably give you you need some knowledge of programming. You need to at least understand one or two programming languages in IT for you to be really successful. You need to at least understand. You don't need to be a master of them, but you need to understand, like, for example, Java. If you look at a piece of Java code, you are going to be using applications that are Java related, or applications that are Python related, or applications that are C++. So you understand at least one function, one programming languages that will help you. So I'm just going to show you really quick. So because we are talking about string, so this is Python, and most of the programming languages, they have like system, they have their own syntax, but pretty much majority of the basic programming language, basic things they share, like when you talk about data sets and all those kind of things. So I'm just going to show you here like syntax, Python syntax. So if you look at Python syntax, so what is a syntax? As we launch in the that's no. Okay. A string in Python or any programming are surrounded by either single quotation mark, or double quotation mark. So a string is just like when you say hello world. When you print like this one, they say hello world. Every programming language starts with hello world. So this is a string. Whenever you see anything inside, you see double quotation and double quotation, and then there is if you are dealing with words, if you are trying to write a sentence in a programming, if you are trying to write your name, you put it in a string. That's a string is a data type. In Python, in Java, a string is a data type. You have int. Int is anything that has to do with number, like not just number, anything that has to do with a whole number. So if you have 2, 10, 20, a whole number, you put integer. Int is integer. Int. String is just anything that has to do with like you actually writing like words. And they have to be in either this kind of quotation, open quotation, double quotation, close double quotation, or it can be single quotation, like in the case of, let me see here. So there's no single quotation here, but this is a double quotation. That's double quotation. So this is a string. Anything that has to do with text document, it's a string. Okay. again, you can look at this one here. If you want to learn some programming, just let me know. Like I said, in the next class that we're going to do, we're going to introduce programming. We're going to have a class for programming, like programming on Python or Java. So I have someone who is ready, who is willing to take that class. But this is just the basics. So this banana here, this is a string. You can also put like just one quotation and one quotation here, not instead of double. That still counts as string. Okay. Where was I? Okay. So the description has to be a string. You see that one when I show you like the actual code. And then you have parameters. Parameters are set, these are just set of parameters, things that you want to pass during the creation of your resource. Let's say you want to pass, you don't want to hard code, you don't want to put you don't want to put the like your access key or other information inside the code because you don't want someone to just look at that code and then so you can pass a parameter. That parameter, you will be able to see, like whenever you create, it will ask you, okay, you ask this parameter, enter them here. Like sometimes it will give you like a drop down, and then you have mapping. Mapping is a set of mapping. So if you want to map one resource to another resource, so you use mapping. And then you have condition. It's a set of conditions that you put. If you want one resource to be created before another one, you can put a conditions. And we'll see that again. And then you have resources. So the only required aspect in this template is this one, resources. Everything else is not required. So you see, we'll talk about, there is more explanation here. And guys, this slide is in the classroom. So you see here, everything I explained. So this the current version, currently the available option. So this is the current available option, this version here. So it has to be there. I told you guys earlier, and then they talk about these resources here. So you see, yes, resource is required. Because this is where you are going to define all the resources that you want to manage or that you want Terraform to create for you. So this is the only required aspect in the template, in the Terraform template. So as you can see, you can have description parameters. So that's 1, 2, 3, 4, 5, 6. But sometimes you will not see majority of this here because they are not required. The only one that you will constantly see in the Terraform template is this resources. So I already explained the description. So it said in parameter, so it's input parameter for customized deployed resources. So I already explained that once. So mapping provide a hash map of value that can be referenced with your template. So if you want to reference, like let's say you have created the VPC, but you want to reference that VPC in the code. So you use mapping to reference, say, hey, I want you to use that VPC that I created earlier. So you can reference that. There's a function for that to reference. And conditions allow you to define conditions controlling when a resource is created, or proprietary is defined. So whenever you define the conditions or what conditions that you want to be taken, like whenever you are creating. And then you have output. So the output just gives you like an output of after the resource has been created, it will give you an output. Sometimes it will give like a URL, say, hey, go to this URL to access your application, or it will give you like the IP address. So it will just output anything that you have to define that though. So this is an example of the Terraform code, how it look like. So this is an example of the resource. So you can see here, it's a resource, and then it's a bucket. And then, so this is a JSON. This is a YAML example. This is YAML example. So this is how it will look like. The code will look like. You have this one at the top, the version, and then you have parameters. So this example parameter that you are seeing here, the type is string, and then the default is capital storage region or blah blah blah. And then you have under the resources, you define the resource here. So this is how you define. Say type AWS : S3 : bucket. Now you define the bucket. So which means you are saying that I want an S3 bucket. And then the bucket, this is where you put it. So you see right now, this one here, it's referencing this bucket's name. So that anytime you see this, how do you call that? Inverted comma. No, that's not inverted comma. That's, even forgot what's the freaking sign? Exclamation. Whenever you see this exclamation and then you see REF, it means it's referencing something there. Okay? So that's what it means here, reference. Again, so yeah, so this is an example, guys. So take a look at this. There are a lot of things here you can learn you can study for the test. I'm not going to go over everything. I feel like I've done justice to this. So this is how it looks like. You are going to see this one when we go to the console. Okay, guys. So that's all for the explanation for Terraform. So you can find this material here. It's here under the CloudFormation site under what is it under? Relevant resources. So you can find it there. So we've talked about load balancer. We'll talk about CloudFormation. I want us to talk about, I'm going to go back to the console. So I want us to talk about the theory. So I have two EC2 instances. Are they running right now? Yeah, I have two EC2 instances running that I created yesterday. But before we talk about this one, I want us to talk about other services first, because we're just talking about a high level since we are not coming back soon to this. So the other service that we'll talk about EFS yesterday, EBS, we'll talk about DynamoDB. So let's look at CloudTrail really quick. We're going to look at CloudTrail, and then we're just looking at a high level presentation of CloudTrail so that you guys know what it is for the test. Again, guys, this information, these are really scanty information. It's really, you really have to go and then do this reading again for yourself. If you really want to be successful, either in the test or you get a job, you got to go and read this information. So you can read about, say, info, you can read the information, but you got to do that. Okay, so CloudTrail, what is CloudTrail? So CloudTrail actually helps to track who is accessing your application and what they did in that when they access. It tracks when they access your resources and what they did. So if you look at documentation here, you can see it will give you explanation, just like we look at the load balancer again. So what is CloudTrail? CloudTrail is an AWS service that helps you enable operationalize and risk auditing. So it's really auditing and governance and compliance of your account. So it monitors your operational and risk auditing. So it's constantly watching to look at, are you following compliance? Are you following the best practice? So it audits your system. It audits for the governance. How are you governing your application? Are you using it the right way? Who is accessing my application? Are they complying with the best practice? Action taken by a user, role, or an AWS service are recorded as events in CloudTrail. So every action that you have taken or that you take in your AWS account are being recorded on that in CloudTrail. They are recorded as events. So events include actions taken in AWS Management Console, AWS command line interface, and AWS SDK and API. So every action that you take in these ones, CloudTrail is recording them. CloudTrail provides 3 ways to record events. So remember this: event history, CloudTrail lake, and then trial. So those are the 3 events. So you remember that. So for event history, the event history provides a viewable, searchable, downloadable, and immutable record of the past 90 days of management events in AWS region. You can search events by filtering on a single attribute. So again, you can, so if you want to, sometimes like yesterday, Mercy stay a little bit and we play a game. I have a game that I have downloaded. So probably we're going to play it today. I'm going to have you guys play this game. It's AWS. It's just tells you like quiz, you have 30 seconds to answer. But basically what this, the event history is, it can help you to download. I think this question came yesterday about this event history. It can help you to download. If you want to download like the record, so you can download that immutable record, so which means the record cannot change, immutable. So you have mutable infrastructure and immutable infrastructure. What are those? While we're here again, and also MUTABL, immutable versus mutable versus immutable. So, okay, let me go to this one here. This doesn't have good information. Okay, let's see. I say in program, immutable and immutable refers to the state of an object. So when you talk about mutable and immutable in program, it's just talk about the state, what state is the object is in, and how variables can be assigned and changed. Data needs to be changed. After all, most sites and applications these days are dynamic, but how that data is changed is what matters. So mutable can be modified. So for mutable infrastructure, you can modify them. So you see, so when you hear mutable, when you hear the word mutable, just think about modify, which means you can change, right? Mutated, which means when you say something is mutated, like some animals can mutate, which means they can change, for example, chameleon. We know chameleon. I've not seen a chameleon. Okay, I've seen a chameleon in the store. But like in Africa, when I was in Sierra Leone, when I was a kid, like we used to see this animal, this chameleon, I used to be scared of them. But they can take the shape of like their surrounding, to mimic. So it's a defense mechanism. So applications, there are applications also that are mutable applications, which means you can change their configurations, their, provision, whatever, you can change stuff, and then once you have created them. So when they are created, you can make changes to them and transform into other data or variables. For example, they give you an example here. And immutable is you cannot change once the data is created, once the service is created, once the resource is provisioned. The only way you can change is you can tear it down and rebuild it again with the new version. So again, we can see, which means with Terraform is mostly mutable. Terraform, that's why you have change set. When you look at with Terraform, Terraform is immutable. CloudFormation is mutable. CloudFormation, as you see, we talk about change set. So which means if you already have created the application, you don't need to destroy everything. You don't need to tear it down. All you need to do is do a change set and then only updates the part that you want to update. With Terraform is immutable, because once you want to make a change, Terraform is going to destroy the original application and create a new one with the new changes. Anyway, so that's the difference between mutable and immutable infrastructure. And then look at CloudTrail Lake. It's managed data lake for capturing, storing, accessing, and analyzing user and API activity. Yeah, so guys, go through and look at this. So they give you 1 year extendable retention period pricing. So this is a question they will ask you. What's the retention period? In fact, when I took the test, they asked this very question here. So that's why you see AWS put it in bold. So they will ask you, these are key things when you are reading this application, just take note of those key things that you see. Sometimes you look at certain things. So for example, what's the retention period of CloudTrail? The retention period they talk about here, up to option or up to 2,557 days, about 7 years. If you choose the 7 years retention pricing option, you see, so you can retain that data for over 7 years. So you gotta take note of those. You gotta remember them or read them, understand them. Yeah, so that's the documentation. Let me go back to, so we're not gonna provision anything, just look around. So yeah, so CloudTrail just gives you an insight of like, ask the question, who? The CloudTrail asks WH questions. Who? What? When? How? How did they get into my application? Who got into that application? What did they did? At what time? So it asks those WH questions. If you go back to like back in the days when we were in school, those WH questions, that's what CloudTrail asks, you know. So it keeps track. So think about CloudTrail like when you go to the beach. Imagine you are at the beach. Every time, like especially like maybe not like, so, because sometimes you go to the beach and the ground is really hard. Even when you walk, you don't leave any trail. But imagine like if you're on the beach and the sand is loose. So every time you take a step, you leave a trail, you leave a footstep, you leave an imprint. Every time you take one step, you are walking around. So if you go to the beach, you stand there, you can see multiple, lot of footprints of people who have been in that beach or on that beach, right? So that's like CloudTrail. So every time someone log into your AWS account, or you create a user, they log in, they leave what they call a footprint. They leave a trail. That's why I call CloudTrail. Just like when you go also to hiking, you see like trails. Trails will lead you to somewhere, and it tells you like, okay, these people are using this, or animals are using this. That's how hunters, they hunt animals. They look for trails. So that's what CloudTrail does for you on your AWS account. So remember, for governance, CloudTrail meets your governance, compliance, auditing. So those are the functions of CloudTrail if they ask you in an exam. All right, guys. So that's CloudTrail a little bit. You know, we are not going to do demonstration on this. This is how it works. It captures the information, the data, and then it store it. And where does it store this one? Majority of the time, it store it in an S3 bucket in your account, right? And then action. You can configure CloudFormation to perform actions for you. You can review whatever things that happen. Where are the benefits? Simplify compliance, visibility into your user and resource activities, security automation, security and analysis and troubleshooting. So guys, that's the use cases, compliance audit. So sometimes you have people coming auditing your organization for compliance, because when you decide to go to do cloud computing, you have to follow certain compliance standards. One is like the California compliance standards. I will show you guys when we are talking about like when we come to that those compliance. So you got to make sure. So that's why you use that compliance aid, security analysis. You want to make sure that you are aware, you know who is doing what, and who is accessing your application. Operational issues, troubleshooting, data exfiltration. I don't even know what this is. You can detect data exfiltration by collecting activity data on Amazon objects. Lambda function. Okay. Guys, so this is all about CloudTrail. So the next thing is I'm going to go to these three guys here. So luckily they just put them here. So there's this one. Let's go to this one really quick. AWS config. Well, I've someone reached out to me last year. They got hired, and then they have this project. These projects they were working on, they assigned to them, and basically the assignment was their agency. They want to know like all the services that they have running on their AWS account. list all the services, and they didn't know how to do that. So there are multiple ways you can do that. One way you can do it is with AWS config. Let's look at that. Let's look at the documentation for AWS config. So today I just want to make sure that we are covering like the most. So it's going to be more stuff like talking, and then at the later part, after the break, when we come, we'll do a little bit of talking again, because I want to make sure that justice is done to all the other aspects before we move forward. What is AWS config? AWS config provides detailed view of resources associated with your AWS account, including how they are configured, how they are related to one another, and how the configurations and their relationship have changed over time. Guys, this is self-explanatory. This is self-explanatory. So it gives you a detailed view, like what resources do I have in my AWS account? How are these resources configured? How are they not only configured, but how are they interrelated? Do I have a database? What is that database attached to? So AWS config will tell you that. And this was exactly, I pointed out that lady, I said, hey, go check out AWS config, right? So what they say here, developers, it's mainly for develop. So you have developer guys here. So you can also see the PDF. So these PDFs are really good. So it's good to take a look at them. So that's a high overview of AWS config. Let's see here, return to console. Maybe this one, I think it's not too cumbersome. Let me see if we can look at AWS CONF. Let me just start it here. So if you click on get started, so here's the thing. Add your application and create one or more logical environments to deploy, validate setups, syntactic and semantic validators. Okay, let's watch this video really quick. Let me share my screen. I think my sound is shared already. So let's watch this video. Can you guys hear the sound?
No.
Okay, no. Now.
To accomplish this, teams either deploy new versions of application code or make application configuration changes and may have to restart their apps for the changes to take effect. Code deployments can be time-consuming, and even a simple configuration change may cause customer impact or even outages. AWS App Config makes it easy to dynamically roll out application configuration changes in a validated, controlled, and monitored way. Developers can deploy code first, and then, with AWS App Config, they can release new functionality by toggling a feature flag, independent of the code deployment. Likewise, DevOps engineers can tune their applications to cope with operational events. AWS App Config enables you to create configurations in any format that works best for you. Centrally manage your feature flags, operational flags, or any configuration data you might want to change at app runtime. AWS App Config also allows you to validate configuration data prior to deployment. Adding validation logic ensures your data is free of syntactic and semantic errors, thus mitigating the risk of outages. Another benefit of AWS App Config is deployment and monitoring. Roll out the validated configuration changes instantly or gradually. AWS App Config can monitor the deployment and automate.
I think this is a different video. Yeah, so that's a different one. That's no. So this is app config. what I want to look for is
so I saw AWS config and AWS app config. So it looks like you chose the app one.
Yeah, I chose the app one. Sorry about that.
Okay.
Yeah, I meant to do the config. So this is what so like I explained, it provides you with a detailed configuration, so you can start here, get started, or you can say one click start setup. So let's do this one click setup and see. Okay, so you have resource type, MRO. I mean, we are not selecting anything here. Okay, so these are all the resources. It's going to check for all these ones. Let's see if it's going to show anything on mine. Okay, so let's just view dashboard. Guys, this is going to be a really, really good service that will help you in your journey, or even after you've gotten, let's say you got a job, this will help you. So right now I don't have a lot of resources here, so probably you will not see many things here. Yeah, I'm not really seeing a lot I don't have a lot of stuff. I don't have basically anything in here. So you have this thing they call rule. A rule is compliance check that helps you manage your ideal configuration settings. AWS evaluates whether your resource configurations comply with relevant rules and displays the compliance results. So if you add a rule, so you can set a rule here, add manage rule, create lambda rule, and all those things. You can create a rule here. So they have like the detective tools, like we talked about CloudTray earlier. CloudTray is one of the detective tools that you can do. So we're not going to do this. Maybe we can come to it again. So resources. So from here, search existing and deleted resources recorded by AWS config. For specific resources, view the resource detail or resource timeline. The resource timeline allows you to view all the configurations items captured over time. So you see here, you have different tabs here. You say resource category. So you say, if we say all here, so you see right now, it got all this information, resource identifiers, type of resource, compliance. So it has all these resources that I have. And then you can put like the type here if you want any specific type. Let's say we want like EC2, like compute services. So right now I say all resources. So you can streamline it to say let's say EC2 instances. So let's say EC2 instances. So you see, it gives me like all the instances that I have created, and this one can be either. So you see, you can even see more. There are a lot. So this include like even the ones that you've deleted, So it keeps tracks of everything. So let's say if I apply that filter, so you see a pickup, like a saying that I have two instances right now that are in this account, right? So whatever I have, so if you select, you have to select something here, the resource, right? So if you select all, it's gonna give you everything that you have, the configurations. So if you go at your job and then, so if you want to know, okay, are they compliance? And then you apply that, it will tell you, so I don't have no resource pass your filter. So I don't have anything about compliance, right? So guys, this is, so you can't just come under here, resources, you know, it's pretty easy, it's pretty simple. And then look at them, play around this one also. Okay, so I'm gonna go back. Really want to go back to that page where we were because it was easy. So the other thing I want us to look at really quick is CloudWatch. Let me see. It's not here. So CloudWatch. So this one, CloudWatch. So CloudWatch is almost like CloudTrail, only that CloudWatch, it monitors, it provides like system monitoring, like application monitoring. CloudTrail monitor everything, like your account. It monitors everything. CloudWatch, again, you can see here. Let's see what the documentation say about CloudWatch. Where is the documentation? So guys, basically what CloudWatch is, CloudWatch, like I think I mentioned it last time in one of my explanation, is like a CCTV camera that is sitting on your applications, or not on just on your application, in your AWS account. And its sole job is to just check like the health of your application, to check like which applications are healthy, whether they are healthy or not. It collects logs. So that's why you see here logs. So you can set logs. It can tell you like the logs of like the cloud live trail, logs, anomalies, like things that are strange, log group, log insights. So if you click on log group, like you can use CloudTrail with AWS Lambda, and whatever Lambda does, it can send that log to CloudTrail. So you can create a log. So you can set up alarms. So the alarm that you set, so let's say if I have any alarm here, I don't think I have any alarm, but if I have any alarm here, CloudTrail can monitor that alarm. When the alarm goes off, CloudTrail I can set an alarm here. So if I set an alarm, I can set like metrics, graphic metrics, right? So I can select and then choose like what kind of metrics do I want to get. So you have different options here that you can choose. You know, you can do a certificate manager, config, DynamoDB. So pretty much all the services, EC2, you know. So again, you talk about like metrics, what kind of metrics? Application metrics, system metrics, you know, compliance metrics, and all those kind of things. So it's a pretty cool service because it helps you to know like what is actually like, it gives you insight about your application. So even on your EC2, if you go to EC2, you will see the CloudTrail. So if we go to EC2, we'll see that even though we don't configure by default, it's like collecting those metrics for us. So if I open like one of the instances that I have, so I have these instances that I have them running right now. So if we look at them, you see like it will give us some metrics, like the performance. It will tell you like your CPU. It will give you like a graph, like your CPU is like. So if I click on this right now, and then I go to like monitoring, I should be able to see some. If I say CloudWatch agent metrics, so you see some events there here. So it gives you like CPU utilization, network, network out. So network in, network out. So what is coming inside and what is going out. Network packets. So this is how the internet works. The internet works with packets. You know, you send packets information and then that information being decoded. So these are all things like CPU credits, you know, it can tell you like how many credit do I have on my AWS account. So these are all like metrics that you can configure CloudWatch agents, manage detailed monitoring. So if they ask you about monitoring, if they talk about monitoring, just know it's cloud for AWS CloudTrace. So CloudTrace is just one application monitoring that you can use. Okay, let's look at here the other services here for let's look at, so there are a lot of things in here. So under network and content delivery, another thing one thing I want to talk about is so you have this direct connect, which we'll talk about, but I want to talk about CloudFront. So CloudFront, it's called CDN. It's a content delivery network. So this is what brings your application closer to your customer. So that's what you need to know. It's a CloudFront. It's a fast content delivery network, CDN. So when you hear the word CDN, sometimes they are not going to use CloudFront. They are just going to say CDN. So just know that this is CloudFront, content delivery network service that securely deliver data, videos, applications, and APIs to customers globally with low latency and high transfer speed. So the purpose of CloudFront is really to help ensure that your customers are getting the best out of the best. You know, so if you have, again, I've explained this the last time, if you have customers that are in Nigeria, you have your web application and you have let's say you have majority of your customers, or let's say majority of my customers are coming from North Virginia and all those things. So I want to make sure that application is closer to them so that they are not like having latency issues. And so I'll put a CloudFront distribution in front of my application. And what CloudFront distribution does actually, it goes into whenever a user make a request. Okay, so I'll finish this and then we can take a break. It's 6:30. Whenever someone make a request for an application, CloudFront is gonna go and get that request from your application from the main server. But what is happening is it have what they call caching. I've been talking about caching for a long time. So even on your browser, sometimes I will say clear your cache. So caching, again, I give an example like you going to get a ice cream every day. You want to eat ice cream, and then instead of going every day to buy the ice cream, just buy a freezer and then fill it with ice cream, so that the next time you want to buy ice cream, you don't need to get outside of your house to go find ice cream. So that's what caching is. And CloudFront works with that kind of architecture, wherein when a user make a request, it's gonna, if the information is not cached in the CloudFormation distribution, what happens is it's gonna go to the main server and get that information, and then it's gonna bring that information and give it to the user. But let's say 2 weeks later, this user wants to come and access that same information. Now, when they make that request, CloudFormation is gonna look first into its cache. If that information is there, then CloudFormation is just gonna send the results to the user. Then the user will be like, wow, I'm watching my Netflix. So that's what Netflix does, content delivery. That's what Netflix. So if you go to Africa, you get different content. And imagine Netflix is sitting right in the US or wherever they are sitting, but you are in Africa, somewhere in Africa, you are able to, or somewhere in Asia, somewhere in whatever, you are able to access their content. It's because of CDN. It's because of content delivery network. So they are bringing it helps to bring that application, because if everybody, whenever they want to access Netflix, they have to log into this server here in the US or wherever, maybe the server is in India. they have to log in. So do you know, like, it's a long time, even though it's through the internet, it's very long, and a lot of things can happen. It can slow down your internet because of the more the distance, the more the worse the connection, right? If your bandwidth is not strong. And so CloudFront help to remedy that. CloudFront, the other reason why also we use CloudFront is to fight against like any attack. You see where they talk about here, attack, DDoS attack. This is called distributed denial of service. So distributed denial of service is wherein people are like they are just sending requests. They send thousands and millions of requests to your application, and their goal is to overwhelm your application so that your application can crash, or so that they can make your customers frustrate. So that, because if fake requests are coming in, people are coming into your application, they are fake, they are not legitimate users, they are just like hackers trying to get to destroy your system, then it's gonna stop the legitimate users from accessing the application, because the load balancer is gonna try to like load balance that information, and then it's gonna take a long time. So the people are gonna get frustrated because they cannot access, because too many traffic is coming, and then the load balancer is gonna get overwhelmed, and then the server will get overwhelmed, and then your server crash. So that's what the DDoS means, distributed denial of service. So CloudFront is a good candidate, good software to help prevent that, in lieu with WAF. So we are gonna stop here for the break. When we come, we can look at WAF, what WAF is, and then we can look at that. There's a demo on WAF that probably I'll give you guys, but you guys have not done that, the assignment I've given. So that's why I don't want to give more other assignments. But let's take a 15-minute break. Let's come back. It's 10:35. So let's come back at no, not 10:35, 6:34. So let's come back at 6:50. Is that okay?
Yes, that's fine. Thank you.
All right, guys. So I'll see you in 15 minutes. So on that, so containerized applications, so container services. So I'm going to talk about like what containerized means, like when we start. By next week, we'll probably talk about that, or the week after that, we'll talk about container services or all those things. But containerized, so pretty much all companies I've seen, I've applied to, they are all using containerized application now. So we'll talk about that, what that is. But Amazon has its own. So I wanted to really, before we talk about it, I wanted to talk about like, so there is this thing we call in IT, they call open source and closed source. So open source applications are applications that are open to the general public. So for open source applications, these applications, you don't have to sign like an agreement for you to use them. In fact, you can even you can get the code and then change it to fit your own needs, and then you can own it. They are open. That's why they are called open source. They are open to the public. So the public have the API that the application is running on, so you can use them. Closed source applications are applications that you have to sign an agreement. When you sign up, you check a box, say, I understand terms and conditions, you follow the terms and conditions. So an example of an open source platform is Windows. So Windows applications they are stringent. You have to sign up. You have to agree. Every Windows application, if you guys can agree with me, for those Windows users, for you, when you are doing anything, they ask you do you agree to the terms and conditions, or Windows terms and conditions? You have to agree to that. So that makes it closed source, because it's not open. Not everybody can get the API. Not everybody you can just go and start changing stuff like that. Windows have to know whenever you are changing anything, and then they have to approve before you can even make changes. And that's why also a Windows application, if you break that, they can even sue you if you do something to their systems without like because you are breaking the contract. So you can look through, like whenever you are sending those things, make sure that you read through the contracts to make sure you know what you are doing. So open source don't have that. So some of the applications that we're going to use are open source, like Jenkins. We're going to use Jenkins open source. Who can tell me an open source application that they are currently aware of? Who can unmute and tell me about an open?
What about Terraform?
Yes, Terraform is open source.
Yes.
Stack.
Stack Overflow. You mean Slack? You mean Slack?
Slack.
What?
Yes, please. Slack.
Okay, Slack. Yes.
Okay.
Yes.
What about Jenkins?
Jenkins is open source. Jenkins is open source.
So this Kubernetes tool is open source, right? Kubernetes.
Yes. Kubernetes is open source. VS Code is open source, right? Docker is open source. So there are a lot and lot of them, right? Yeah. There are a lot of, as long as you are not, so whenever you are downloading those applications, as long as they are not telling you that, do you agree to these terms and conditions? As long as you are not, because when you say, yes, I agree, when you click that box, you check that box, you are signing that you agree, you know what you are doing, right? So yeah. pretty much majority of the applications I have used are open source, and majority of the ones that we're going to use throughout this class are going to be open source, because you are not signing an agreement. Now, when you do Windows, sometimes I think Mac has a very strict, but anyway, so that's I want you to understand that the difference between open source and closed source, because Kubernetes falls under that. But AWS went ahead and made their own version of Kubernetes. They call it EKS. Because Kubernetes is free, AWS make their version. So AWS basically will make anything that's out there, they try to make their own. So even the CloudFormation that we just covered, it's Terraform, right? So Terraform is an open source, and then closed source, an example of closed source again is CloudFormation, right? It's because it's only AWS. It's closed, So we'll go over this. We'll go over Kubernetes in detail, but I want us to look at this first. Let's look at this ECS, which is Elastic Container Services. So this is just like Docker, right? So Elastic Container Service, because it provides containerized environment. Let's look at these ones under these container services, because these are really important. We're not going to do demo on them, or maybe we will do it at some point, but not now. But it's important for you to know like what they are. This class is really to help you understand what these tools are, and then you can do further research or even demonstration, or listen to tutorials. So let's watch this video. I'm gonna share I think my sound is here. Let me know if you cannot hear.
Containers deliver speed and agility for your business, but can require a lot of heavy lifting. Running complex container orchestration software, managing and upgrading the orchestration systems, having disjointed processes for hybrid environments, not to mention managing cost and security concerns. Your time and your developers' time is better spent focusing on projects to help grow your business. This is how Amazon Elastic Container Service can help. Amazon ECS is fully automated with no control plane to manage. And with ECS Anywhere, customers can work with containers in both a cloud and on-premises environments. Combining ECS on Fargate, customers don't have to manage hosts. No patching, upgrading, or maintenance overhead. ECS delivers security, cost control, and simplicity, while removing the burden from your teams, end to end. Innovate faster, reduce overhead, and spend more time deploying projects critical to your business growth.
Guys, I'm gonna pause it. Everything that she has said from the beginning to this point right now, she's just defining automation. That's automation. That's just automation.
Build pipelines with agility and speed for networking, storage, and automated scheduling that scale automatically. ECS seamlessly integrates with other AWS services. If you know AWS, you know ECS, and teams can also run containers on compute services such as EC2. using the ECS fully managed control plane. Best of all, there is no additional charge for Amazon ECS. You only pay for the AWS resources you need to store and run your application. Get started with ECS today.
So that's ECS briefly on from AWS themselves, right? So, I mean, there is a lot to it, but she made mention of this one here that you say Fargate. Fargate is just like, if you don't want to use EC2, you use Fargate. Fargate is under the category that I said, serverless applications, just like we talk about Lambda. You don't have to worry about the underlying infrastructure. That was what she explained over there, right? You don't have to worry about like the operating system, what the operating system on which Fargate is built upon. On the other hand, with EC2, you have to do everything manually. You have to go to create instance. You have to select the operating system, whether Windows or Linux or Ubuntu or Red Hat. You have to configure security groups. You have to configure VPC. You have to do all these things, but you don't have to do that with Fargate. That's why it's called serverless. Serverless is on the end of you, the customer. You don't have to deal with server, but it is still running on the server on AWS side of things. But you don't have to do anything with that. That's why it's called serverless. So it's not. It doesn't mean that it's not running on any server. That's not what it means. It just means that you, the customer, you don't have to worry about that. You don't have to think about that. You don't have to do anything about it. All you know is your application code or what you want to do. So that's Fargate. And I want to, maybe after I finish talking about this, I'm going to go to Fargate next, just so that we talk about it before we go to EKS. Because EKS, we are going to talk about it even as we are going forward in DevOps. Yeah. So if you don't want an alternative, if they're asking what's an alternative to EC2, if they say we have, and the customer doesn't, any side you want to hear the word, the customer doesn't want to deal with the underlying infrastructure, like the OS, manage the OS or whatever. Think about if Fargate is there, start thinking about Fargate. Start thinking about Fargate. Because this is serverless. And even this Elastic Kubernetes services is also serverless. That's why she was talking about that. You, the customer, you don't have to worry about all the headaches to deal with the underlying infrastructure, because AWS is taking care of that for you. So with ECS, I mean, there's nothing much I will really gonna say much here that she didn't talk about, right, in that short video. But again, like I said, serverless options, application force capacity provider, I already explained what is serverless, performance at scale. So Amazon ECS powers several key services that Amazon at Amazon, and is built on technology developed from many years of experience running highly scalable services. So you can rapidly launch thousands of containers using ECS. So this is where many, right now, the modern day technology, project delivery or software delivery, they are using serverless applications. Serverless, you don't have to deal with the underlying infrastructure, and it's easy, it's portable. One of the main benefits of serverless application, what we are going to see in Kubernetes, is because of its size. It's very easy to maneuver around. It's very easy. You can package it and then send it to your team or whatever. As compared to if you have to if you are dealing with all the operating system, all the underlying infrastructure, those are hard to manage. They are hard to be scalable. You can scale them, but it's challenging compared to serverless or ECS or Kubernetes or Docker. So it's security. Amazon ECS runs your containers in your own Amazon VPC. And so which means because it's running in your own VPC, it gives you the power. It gives you a lot of control for you to grant who can come in and who cannot come in. So the ACL, access control list, who can access my application and who cannot, right? So it gives that control because it's inside your VPC. And remember, the VPC, your private cloud, right? Amazon gives you a virtual private cloud. So whatever resources that are inside that VPC, you have absolute control over. Unlike if they are in a public VPC or public cloud, you don't have control. You can also assign granular access permissions for each of your containers using IAM So yeah, so again, we learn about the IAM permissions and policies, so you can create a customized policies and permissions to control like the user behavior. It is cost optimized, it is reliable, use case is batch data processing. You run your sequential and parallel batch workload on Amazon ECS using AWS batch. Web applications, so they use it for web applications. So if you want to use like a web, host a web app. So to create an ECS, you have to create a cluster. So you click on create cluster, and then you say create cluster, and then you can, I'm not gonna do it, you can give it in the cluster name. So you can define a namespace. So select the namespace to specify a group of services that make up your application. You can overwrite this value at the service level. So they're asking you right now to create a namespace here. So you can create a namespace also. So what kind of infrastructure? So they give you optional here. You can choose either between Fargate or EC2. You can choose which kind of infrastructure that you want to create. If you want to create Fargate, then you select Fargate. By default, you see it's selecting Fargate because it's very compatible. It's compatible to EC2 also, but it does really well because they are in the same family. You can configure monitoring here, so you can say, so right now by default it's turned off. So if you are playing with it, keep note, or I keep telling you guys this. So the recommended is, they'll ask you what is the AWS recommended. So you see the AWS recommended, it stays here. So which means it says AWS is recommending container light, container insight with enhanced observability. So that's what AWS recommend. What does that do? It provides detailed health and performance metrics. So the CloudWatch that we look at, it provides that container level in addition to aggregated metrics at cluster. So you see, that's what this do for you if you select this. So AWS recommend that you select this, but by default, it's going to be off. So those are the things that we try to trick you on. And then you can encrypt it with KMS. You can add a tag, and then you can go click create cluster. So you have namespace here. Like I don't have any namespace here because I've not created this. You can see the tax definition here. If you click on tax definition, so right now there is no tax definition, but you can create a tax definition. And so again, you want to learn about tax definition, you come here. The tax definition views list each tax definition family you have created. So whatever tax definition that you've created, it's going to be there. Yeah, so this is ECS. Let's go back to one way to look at a container, so think about it like when if you want to ship, let's say you have a car dealership business let's say I have a car dealership business in Sierra Leone, and every month I ship like maybe 50 or 100 cars every month, Well, when you go to the dock, you see like in the ship it has this big stuff where they put multiple containers upon layers. Well, that's how container services works. It just provides a platform, the environment, so that your application can coexist with other applications. They can even communicate, but they are not dependent on each other. So again, I'm not gonna go into detail for this right now because it's a huge topic. We're gonna talk about it when we start talking about Kubernetes. But that's how you can take a look at containerized services. I mean, if you even Google it, that's what you see information. If you type So, and a typical example. So maybe I can talk about this briefly anyway. We can also talk about it when we talk about Kubernetes. So okay, so traditionally this is the structure. This is just a high level of this is a high level thing I'm gonna say description. This is a traditional method of like application deployment or delivery, if you may say. So you have the hardware, and then on top of the hardware, so the hardware is like where your operating system, your like your kernel. This is like where your kernel exists. Like even your computer, the computer that you are using to join this Zoom. This is how it has the hardware. So you talk about your CPU, you talk about your RAM, all the storage, all the GPU, and all those kind of stuff. That's where they exist, you know. And then on top of that, there's a software called hypervisor. The hypervisor, the purpose of the hypervisor is to bridge between the hardware and the software. They sit in between that, you know. It helps to enhance that communication flow. They serve as an abstraction between the OS and then with the hardware. And then on top of that hypervisor, so here you see like Hyper-V and all those kind of things. There are different hypervisors, you know. On top of the hypervisor, you have the OS. And this is a traditional method. You have the OS, which is the operating system. So this could be a Windows, this could be a Mac. I mean, this could be a Windows, this could be a Linux, you know, CentOS or whatever, or Ubuntu. So these are the operating systems. The operating systems are the software that helps this hardware to actually perform its functions. Without the software, the hardware is nothing. So without the hardware, the OS is nothing. So they work hand in glove, but there is a middleman in between them, which is the hypervisor. And then on top of the operating system, you have the VM, which is virtual machine. VM. So you see all these layers, right? VM, virtual machine. And on top of that VM, then you install your application. So let's say if we want to install Apache, these are the kind of things, right? We have our hardware. On top of the hardware, we have the hypervisor. And then on top of the hypervisor, we have the operating system like Ubuntu. And then on top of Ubuntu, we have the operating system Ubuntu. On top of this Ubuntu, we have a virtual machine. Maybe this can be like an EC2. And then inside that EC2, we have our application. So this is a traditional method. Companies are moving away from this. They are shying away from this. Now they are coming to this one. They call it microservices. Microservices, they are called micro because they are very tiny, they are portable, they are fast, they are easy, they are less expensive because you are not using a lot of code. So they are easy to manipulate and to play around, to move around, to modify, and you know, to share. They are fast to deliver the applications. And so the architecture is the hardware, so the same hardware here. But now instead of the hypervisor, you have a container runtime. And that container runtime, that's what we talk about ECS. That's where we are going to talk about Docker. Because it's providing that platform, just like I said, it's providing that like a ship. In the hull, you have where in that hull you can stack the multiple containers. So that's the Docker. That's what we're talking about, Docker here. And then inside, on top of Docker, you have your application. You can have multiple applications. So you see, they are all these applications that you see up here. They are all using this particular runtime. They are all in this, which means they are in the same building, but they have separate apartments. Have you guys seen those, like, is it condo? They have those homes, those buildings, like those apartment buildings. It's a big building, but then when you go inside, there are different apartments. Maybe you have a shared living space, and then different, every family have 2 bedrooms or something like that. So it's the same thing here. They are in the same environment, but they are very separate. There's an abstraction. They are separate from each other, but they can communicate if they want to, if there's a need to, right? So this is a very high level. We are going to talk about this more. So what you can see here, containerization is a form of virtualization where applications run in isolated user space. Again, like I said, this is a high level explanation. When we really talk about this, I will tell you what is the user space that they are talking about here. While using the same shared operating system, OS. One of the benefits of containerization is that a container is essentially a fully packaged and portable computing environment. Everything an application needs to run, its binaries, libraries, configuration files, and dependencies is encapsulated. So this encapsulation, this one, is a huge thing, in not only in IT, but in computer science. You know, we will talk about this encapsulation. So it just brings everything together, you know, to try to make each part function as a unit and isolate its containers. So even though they are using on the same runtime, they are isolated. I explained that earlier. The container itself is abstracted away from the host OS. So the container is abstracted from the host OS. So which means it's not on the host OS, because if the host OS go down, the container is not going to go down. That's why companies are going to, the container is, there's this principle called decoupling. You have couple application and then you have decoupled application. Coupled application is wherein they are tightly coupled, they are together, which means if one thing break in one side of the application, it affects the entire application. That's called tightly coupled. And then when you say loosely coupled or decoupled, or let's say loosely coupled is wherein they can still communicate, but they are not dependent on each other. If one of them fails, the other one will still continue to work, but they can still communicate, right? And then when you say decoupled, where you make them separate, they don't have any interrelationship. Yeah, so this is just a high level discussion. We'll talk more about this later on. Let me see if I can remember where we were. Okay, I think we were talking about so we'll talk about that. Let me close that. We'll talk about this one also. So I think we were talking about, okay, so like containerized services. Okay, so that is ECS, and then Amazon also has what we call EKS, Elastic Kubernetes Services. So we'll talk about ECS as a provider environment, like this one we talked about earlier, this one here, that provide the environment for abstraction, right? The computing environment. Well, with EKS, it provide orchestration. Like it's more, I'm not going to go into that. But I want you, it's provide orchestration. It's not just providing environment, it's provide orchestration, right? How is your application being orchestrated? So Amazon EKS is a managed service that makes it easy. When I say I'm not going to go into it, we'll go into it like when we come to Kubernetes. That's what I mean. So Amazon EKS is a managed service that makes it easy for you to use Kubernetes on AWS without needing to install and operate your own Kubernetes infrastructure. So again, like I said, AWS, any service that is out there, AWS at least try to make their own. But they also have partnership with some of those services also, but they try to make their own stuff. So Amazon EKS auto mode. Okay, so this is just telling you about the auto mode. Again, the documentation is here about EKS. So we'll just talk about it because we'll probably not come to this one, this explanation. We'll just probably do demos when that time comes. So, so you have the developer's guide. I don't know which one we should look at. Let's look at this. This one, this user guide. It's Amazon EKS, Amazon Kubernetes Services is the premier platform for running. So this is a platform as a service. We'll talk about that for running Kubernetes clusters, both in Amazon Web Services, AWS Cloud, and in your own data center. Amazon EKS simplifies building, securing, and maintaining Kubernetes clusters. It can be more cost-effective at providing enough resources to make peak demands than maintaining your own data center. EKS standards. Amazon manages the Kubernetes control plane. So the control plane, we're going to talk about what the control plane is like when we come to Kubernetes. But Amazon manages that control plane when you create a cluster. Components that manage nodes, schedule workload, integrate with the AWS cloud, and store and scale control plane information to keep your cluster up and running are handled for you automatically. So basically, Amazon is covering majority of the workload. You don't have to deal with anything like the OS level. So they have like this auto mode, feature. EKS extends its control to manage nodes as well. So that's if you select this auto mode. So this is like what it looks like, So you have the manage control plane, and then if you have any add-ons, so this is like the customer account, and then this is like the EKS account. So manage the control plane, and then you manage you have like instances, yeah. And then what are the features of EKS? So one, it has the management interface. It has the control tools, compute resources, storage, security, monitoring tools, Kubernetes compatibility and support. Yeah. So it's for orchestration. Again, like when we go to Kubernetes under DevOps, then you understand really what I mean, because I will dive deep into what orchestration means and how it works. But so EKS, all you need to know is just a version of Kubernetes on Amazon. So it is lightweight also. So it's not much expensive. It's not expensive like Kubernetes, the actual Kubernetes. Yeah, so we'll create some clusters when we come to that. Okay, so what else? So we'll talk about Fargate. So again, you can look at Fargate. So if you type Fargate, so have Fargate. I think that's just taking documentation Fargate. Yeah, so Fargate, they are both. Fargate and Lambda are both serverless applications. But Fargate is like again, like I said, it's an alternative to EC2. So it's a serverless compute engine for containers, primarily used with ECS. So the primary use case is with ECS, the ECS that we just talked about. It automatically manages your infrastructure, allowing you to focus on deploying and scaling and containerized applications. Fargate is ideal for long-running applications. So if you have applications that are going to be running for a long time that are not going to be shut down, so you use Fargate. So if they ask you in an interview or in the exam, the customer has a long-running applications and they are thinking of using which a service that will help them to manage, that they don't have to manage with the OS and all those things, which service to use, then they say ECS, or they say Fargate, EC2, S3. Definitely you should choose Fargate. So this is not the Fargate page. So if you go back to the Fargate, so if you go back to the main screen, if you click on all services, when you're on the home page here, if you click on view all services, it will take you back to this page. And then if you go under Fargate, it's under compute services. So under compute services here, if you look, well, not under compute, it should be under, where did I see it? The networking, not networking. It's under application integration. No. Why can't I find? Guys, if you see it, let me know. It was just, yeah, it's here somewhere. Again, we don't have to do all this, what I'm doing. You can just search for it on the search bar. You can just search FAR. Okay, so let's look at the Fargate pricing. Maybe that will take us to the console. I don't know why I can't find it. Maybe I'm log me out. I'm logged in. Anyways, well, you can. It should be here.
What are you looking for? You're looking for Fargate?
Yeah.
I don't have it either.
Yeah, that's interesting. Yeah,
but I see the documentation though.
Yeah, I see the documentation myself, but and it was there earlier. Something is probably there's gonna be some glitches. Anyway, so but it's an alternative to EC2. If you want a serverless version of EC2, so you use that, and mostly it's used with ECS. So with Kubernetes services, like I said, we are going to talk more about it when we come to Kubernetes itself. But if you don't want to use Kubernetes, because Kubernetes can be really expensive, because Kubernetes creates a lot of things for you, so it can be really expensive. So an alternative, if they ask you for an alternative to Kubernetes, talk about EKS. There are lots to learn about this, but we are not going to cover those today. We'll cover them like when we are diving into Kubernetes itself, because I want to make a dedicated class just for that, because it's one of the most important things, that will help you land a job. Okay, so what time is it? So we have 30 minutes. Let's go do that. I said we're going to do some demonstration. So let's go back to, I have a lot of tabs open. Let me close some of them. So any questions so far while we are doing this? Any questions? Just going to close some of these tabs. So we're going to do some demonstration. The only thing I will warn you is one of the instance I run it yesterday, I run the same code. So it's really interesting. Sometimes I don't understand how I run the same code, one code, and then they create two instances for me, and then they have a user data, and one of the EC2, the user data is working, and then the other one is not working, but it's the same code. Okay, so we talk about CloudFormation, guys. So this is CloudFormation. So I have a stack here. So you see, I try a lot, it fails a lot. So when it fails, don't get frustrated, just keep trying. So this stack, I have it stacked. So when you come to the console, I'm going to delete this, then we create another one. Like I said, automation, it's easy. So I'm going to delete this. But before I delete it, take a look at, so this is the output. The output session will give you like the output. So it tell me, say, go to this IP address. Now, for me, this IP address, it doesn't really work sometimes, but let me try it. Because when I try to get it, it gives me an error. Even though the thing is working. Maybe it's working now. Nope. Yeah, so it gave me an error like that. Maybe it's my VPN also. Who knows? I'm going to put it on the chat. You guys can try to access them and see if you can access them. We are going to tear them down anyway. So just try to go to those links and see if you will be able to. So I'll send this one. I just want to see if it's not my VPN that is blocking. So I want someone to go to this first one, and then I'm going to send the other one. Go to this other one. These are two instances. Can someone go to those links, and if they are able to access this before I delete this?
Do you want to share it on the?
No, just let me know if it's on the group, not the group, the Zoom chat.
Okay.
They are there. You just have to click on them. I trust you. They are not infected with virus.
So this traffic is being served from server B.
Okay, so which one is telling you that? Which IP address?
The one that ends with 117.
117. Okay,
Yeah.
Did you try the one that ends with 1157?
No,
So the 117 is working, so that's what I expected. It said this traffic is coming from server B?
Yes.
Okay. Jordan, you got the same thing, right?
Yes, and that first one is not working. It says the site can't be reached.
Yes.
It refused to connect, checking proxy and firewall.
Yeah. So that I experienced that. So I'm gonna tear this down. I will show you guys here like how this works. So when I say tear it down, this is what I'm gonna do. I'm gonna select it and I'm just gonna delete it. Delete this stack. Now you can put protection on this stack. So it's gonna go through that this again, say deletion. But I'm just gonna walk you guys through on this interface here, this user interface, this UI. So when you got into your CloudFormation page, and how did I come here? And I'm gonna go back just for people who are still saying, hey, how did you go? How did you get there? So I'm gonna go back. Just gonna type CloudFormation, type CloudFormation and then select it. I will take you to this page. So on this page, you will see if you have any projects that you have run, if they run correct, you see them all here. So all this my project failed from, I think I did, and you can see the dates, the timestamp. And then you can delete. So like any of this, I can select it and then I can say delete. If it's not already deleted, it can delete it. You can update the stack, so I can select this one. If I say, let's say I wanna, so right now I think this one is deleted, so that's why it's not highlighting anything here. You can go to stack action, and then you can edit templates, and then you can view different results. You can view in application manager. So under that stack action, if this was actually a running stack, you can see delete drift. So drift, if there's any configuration drift, if there's any differences in terms of like what the actual one is, and let's say you downloaded like HTTPD, and then you down a new version, and then you later on you download another version, it's gonna give you a drift, right? So you can also see like a grayed out. We are not able to choose anything here. You can say create change set, which we already talked about, import resources into stack, cancel updates, all these things. Yeah. And then if you want to create a stack, you can just come here, you click on create a stack. And then you can create a stack new from new resources, or you can create from existing resources that you import. On the left here, you can see like you can see details about the stack. You can see if there's any drift. So it's just a difference. And then you can see stack set. You can explore, export, and infrastructure composer. So this infrastructure composer, this one, if you click on that, so this one just gives you, for people who are not good, if you are not good with coding, like writing the codes, this infrastructure composer helps you to, we'll see what it will do. It's drag and drop features. Yeah, so it's a drag and drop features. So it has a canvas here. So let's say you want this API gateway, you can just drag it here. And so it's here. Then it has this connector here. So this API, you can connect it with other services here. So let's say you want this API to be connected with this Cognito user pool. So you can, it's not connected because, or maybe you can bring this down here and then bring the user pool here and then try to create the connection. Anyway, yeah, so this is so you can do this, something like that. You know, it's not connected because they are not compatible. Yeah, you can create resources here. They are not compatible. If they were, no sooner you move this, it's going to connect, right? You can delete the stack. if you want to see like this, what I've done right now, you can see the template, the code version. So you put it in the code. So this is the code. Just for that these two things I have in the canvas here, and that's the code on the back end. So if you want this code, you can just copy this code. You can run this code. You can create a template out of this code, you know, and you can either choose. So in here, I'm going to show you. I will show you again. Well, I'm not going to explain it. I'm going to explain it here. In here, so you see the template. We'll talk about this earlier. This is the version we'll talk about, and we'll talk about the resource, right? We talk about description here. They don't put a description, but after this, it should be like description, but that's optional. The only thing on the template I explained earlier that is required is this resource. And so under resource, you have everything here. So with YAML, so this template is currently in YAML. I explained earlier what YAML is. It's currently in YAML. And how do you know it's YAML? So you see the indentation like these lines. It's a structure. So the resource is on the outer line, my left. So you see the line, and then you see API. And then, so you see how they are ordered. So API is under resource, and then under API, you have type, right? And then you have name, and then you have path, and then you have the home, and then you have get. So that is the structure. So YAML is very good. It's very particular about this indentation. It's very particular. I will show you in VS Code. It's really, really particular about this indentation. Now, if we switch it here to JSON, it's different, right? So JSON is this curly bracket. So you see each and every of these brackets correspond with another bracket. So you see when I click on it, you see it's like this. If I click on this one, it will tell you which one corresponds to this. So if I remove that one, you see the entire code get an error. If I put it back, the error will go away. So this is JSON, JavaScript object notation. This is JSON. It's very particular about this, like the blocks. So these are called blocks. So each block, so right now it's still saying I did something.
Oh, quick question. Did you mean that JSON and JavaScript is the same?
JSON and JavaScript? No, they are not the same.
Okay.
Yeah, they are not the same. This is what it stands for. JSON, JavaScript object notation. That's what this JSON means. Okay. But it's really, you can tell the difference. So if I move, so now it's not kind of giving me like failed. I want to go back to YAML. Okay, so I'm just going to cancel it. Yeah, so but you guys, so here you can just click and drag. You can just click and drag. So you can also validate the code. So right now, if I validate it, probably it's going to say something is wrong because of that thing I did earlier. It's still not recognizing it, you know. But if you can validate your code and it will tell you, like right now, it's saying that, oh, something is wrong here, you know, with this curly bracket that I remove and put again, because this curly bracket is correspond with this one. But it's still, just because I remove it, it's still crying that, oh, something is missing here. Yeah. So it's really particular.
So Daniel, it leaves you with the option to know what line has an issue, just in case you get to validate the codes. Like it's telling you line 6, I think line 6 and column 28. Yeah.
Yep. So it will give you that information. So even I'm going to show you in VS Code. We are not going to create this anyway. I just wanted to show you this one. We're not going to create it. But so if you for people who, if you are not good with code but you are good with, like, you know, again, that's why I'm telling you, you have to know how to do this on the console before you start going into code, right? So if you know what you are doing, then you can just come and click and drag and connect them, and then you get your code, you know. But remember, it is in declarative. It's a declarative. It has a declarative format, so you can take things, you can make things, you can, bring, like, you can make changes to the stack. So what I'm going to do is we are going to create a stack, but before we create that, I'm going to bring my VS Code. I'm going to open my VS Code and share it with you guys. So the template that we're going to work on. Can you guys see my screen?
Yes.
Can you see my VS Code?
Yes.
Okay. So we are going to build this ALB EC2. So whenever you create a file, so how the first thing you want to do is you can do it.
Daniel, are you expanding your screen?
Yes.
Thank you.
Is that good?
Yeah.
Okay. So the first thing that so this is my Windows. The first thing you do is you create a file, right? So again, if you can determine where you want to create that file. So if you want to create it like I'm creating it, this is my path directory. So my path directory it's under my E drive. It's under my CloudFormation. So it's inside of, so you see this PC, training materials, and then cloud. So that's where it is. So you got to choose where you want to do that. And then once you are there, so what I did is I'm here. So this is in my training folder, training directory. And then inside this folder, I open it. But before that, I even create that folder. Guys, you know how to create a folder on your computer. So I'm not going to go over that. But once you create a folder, you go inside that folder. And then that's why I told you guys to download VS Code. So when you are inside the folder, you can decide to create this folder here, but you don't have to do that. So you can right click and then you click on show more. And then it will give you options here. You can do open with VS Code. If you see this option, you can say open with VS Code, and then it will open the VS Code for you. So right now I have it open, so it's not going to reopen it again. Another way you can open it is you can say right click again, and then go show more, and then you say git bash share. This git bash, you see git bash share. If you click on git bash share, it will open your git bash terminal. So you open it on my other screen here. Let me bring it here. So you open this terminal, and on this terminal, all you need to do, type CODE and then dot, and then hit enter, right? So when you type that, git is gonna take you to VS Code, right? So my VS Code is open, so it's not gonna take me there. But if this one was closed, it will take you there. So code dot, okay? So those are the few ways. Anyway, so this is the template that we're going to use. So in this template, so what I have here, again, remember I talk about the only required one here is resource. What I have here, the version is 2010, September, whatever. And then, so I put some comments here, CloudFormation template version declaration. So I declare my version here. This one, like I said, it's not a required one, but you have to put it here. Technically, it's the only one required here is resources, but I would say this one, put it there on all your templates. And then the description is not required, but the description is not, even though it's not required, it's a string, but it helps whosoever is looking at this to know what this particular thing is going. So for example, create 2 EC2 instances with Apache web server displaying different bootstrap messages. So that was what you guys saw. Now that instance is no longer there because I deleted that stack. And then under parameters, parameters allow users to input custom values when creating a stack. So I already explained that. So I'm going to expand this. This is not the code, what you're seeing. This is just a blueprint. So I'm going to expand it. Then you can see the code. So this is the code. So this is going to, so I defined all the resources, the parameters that I want to enter. I define them here under parameters. So SSH key. So I'm requesting the SSH key here, name of existing SSH key here, to enable SSH connection. So if I want to connect to that, so I'm declaring this one here. And then EC2 instant type. So this is, I'm declaring the instant type that I want to use. So I want to choose from these options that I have here. So this is called list. This is a list in programming. So I'm giving a list here. So, hey, I want you to select only from these two instances here. So you can do T3 nano, T3 micro, or so only from this type. It's a must be a valid EC2 instant type. So this is a condition. Constraints. So this is a constraint. It must be a valid EC2 instance type. So which means it must fall into this category. And then IP range allow for SSH. So this is where I define like the IP range. Yeah. So I define the IP range here. Allow pattern. So it can allow like /D, and all these kind of patterns here. And then it must be a valid CIDR range. And then from here, I go to resources. So this is the required section. So this is where basically you just list the things that you want to do. The thing that you have to remember here, this AMI, you have to make sure that this AMI match the AMI that you have on your the AMI that you have on your AWS account. So you have to go and click on create instance, and then instead of creating, you just copy the AMI ID just as it is, like you are seeing here, and then change this. So if I'm going to post this code in the classroom, so if you are going to do this, just make sure you change this AMI ID. And then so I put the user data here. So this is the user data. So the first one, this first EC2 instance, this one is going to print. It's going to install. They are going to install Apache web server. Apache is a web server. It's going to install Apache. So this is the bootstrap. So this is just a bootstrap, just like we saw on the other item, the one we did the last time. Again, because we are creating two instances, so we have two sets here. So just make sure you change it here also. So this is the resource section. Just define all the resources, the things that you want to do, the things that you're going to do, or you want CloudFormation to do for you. And then the output section is where what do you want to display? So you see, we say the URL of the server, the IP address, all those things. I don't know why it doesn't work when you click on it. Anyway, so this is just a simple template with just few resources. This can get really, really long. You can create modules. Yeah. So this is right now. Who can tell me which format is this written into? The one that this code that you are seeing. Who can tell me which format? Can someone unmute and tell me which format? We talk about two types of format or language.
YAML.
What?
YAML.
YAML, right? So this is YAML. Yeah, this is YAML. Yeah, this is YAML because of you see the lines, parameter. Under parameter, you have key name, and then this key name. So you see even the indentation. So if you bring this description to the in line with the key name, it's going to throw you an error, right? So that would be like a syntax error. So let me try that. So if you do that, so you see, it has an error here. And with VS Code, today we are not gonna talk about this in this VS Code, but I'm gonna show you. So right now, if you see on my left hand here, on my left, the left on my VS Code, as though you probably have these things, some of these things, but these are all extensions that I install. It can help me to do this, like say, hey, this code is not, something is wrong here. So it's telling me. So usually it's a no quick fix. Usually if it has a fix for you to tell you a fix, say, hey, click here and see how to fix this. But when you see this line, which means your code, something is wrong with it. It's because the indentation, YAML, I told you, it's very particular about the indentation. So if I move the code is working now. So just take note, don't put that. Just take note of, just be really careful about that. That's not what I want to do. Just want to save. So guys, once you have your code here, so right now, let me do another changes. Let me do that again. Let me click tab again. So you see on the left, on the top here, you are seeing something, a little tiny white line. Do you see that? Guys, this white line where it says ALB EC2.YAML. Do you see that dot, like white dot? Right here, where my cursor is. So it turns to X when you put your cursor on it, but then when you remove it, it's like white. Do you see that?
Yeah.
So that means this code is not saved. So if you try to run, if you make any changes and you don't save it, it's not gonna reflect the current code. Okay. So to save it, just do Control S, or you go to up at the top left hand, or your right on whatever now you click on File, and then you click on Save All. Okay. So now this is saved. So now you can only see X instead of that dot, that white dot. So once you are sure that this code is all correct, then you can go back to CloudFormation page here, and then you can click on Create Stack, and then select that one. And here you have different options. You can say create from infrastructure composer. So if you say this one, it's going to take us to where we were the last time, that infrastructure composer. But that's not what we want to do right now. We want to create from existing templates. And then under here, if you have the template in S3, just copy the S3 URL and then come and paste it here. Then CloudFormation will get it from S3. But we don't have it in URL, we have it in our local machine. So we are going to say upload a template file. So when you click on that, it's going to give you this option. Choose from file. And then it's going to go to your computer. So we are going to, you just select the appropriate document, and then it's going to acknowledge it here. And then you go next. So this is where when we put parameters, right, the name. So I'm going to say 5, demo 5. And then I see the parameters, the instant. So right now we have the option to select. So remember under the parameters here, we put a lot of things under our parameters, like the instant type, like this one, right? We put like this, all these things that we selected. Well, that is what it's asking us for now. So now we have the chance to say we want, okay, T3 small, T2 micro. So let's say T2 macro. And then we have the option to choose the keep here also. So you see, it just automatically our keep here appear, you know? And then once you make sure, so this is the parameter, that's the function of the parameter. So instead of hard coding is like when you come and put those information here. So here we are just passing a parameter. Say, hey, when he's creating this instance, we want you to request this, we want you to give him this opportunity to choose the best that that works for him. But you have to define them here. Okay, so once you do that, and then you can go create. And here, if you have IAM role, you can do. If you don't have it, it's going to create one for you. And then under stack failure, so you have two types, the stack failure. So it can roll back all stack resources. So all roll back the stack to the latest non-stable state. So whenever it fails, it's going to roll it back to the original state that it was the stable state. If you select this one, preserve successfully provision resources. So let's say the stack failed because the security group fails, which means if the stack has already created the VPC, if it has already created other stuff, it's not going to delete them. It's just going to only complain about the security group that fails. And then you can just go and do your change and then fix that security group and then run it again. So, but if you do this rollback, it's going to destroy all other resources. So I will choose it because this is demo. I don't want to forget and to delete any other resources. The one thing that you also have to remember about CloudFormation is it can only manage resources that are created by CloudFormation. So CloudFormation, let's say you have these two EC2 instances, and then you create another EC2 instance, but not with this template. Let's say you go on the console and create another instance. When you say delete, if you come and delete this stack, it's only going to delete the stack that were created by the template, because the other EC2 is outside the knowledge of CloudFormation. CloudFormation is not aware about it because they are not defined in the template. So remember, everything that you have, if you want any action to happen, you have to define that in that template that I showed you earlier. And then you have the stack policy. So these are optional stack policy. You can say sticky policy, upload file if you have a file that you want to upload. The rollback configuration, you can put a rollback configuration like monitor the time. You can put CloudWatch alarm if you want that, or you can create one. So the CloudWatch alarm will give you notification for like when the events are happening with this stack. When the stack is created, when the stack fails, when the stack is successful, it can tell you about that. So the notification, if you have like any notification, we don't have any SNS notification. But you can create a topic. Optional, so we don't need anything, so we're just gonna go next. And then this is a review page. Make sure you review and make sure everything is right, and then you go submit. So we are gonna, so you're gonna see the action. So it's gonna go, the first action is the stack is creating now. So we move from template to stack. Now we are creating the stack. So the stack is in creation process. And as you click, you see the events. You see like what is happening. So you see some of them have already completed, but some of them are gonna wait until another resource is created before they can go ahead. So while this is going on, if we go to our EC2 page, we should see, guys, it's 8 o'clock. We are gonna finish this. I want to add it to the load balancer. That's really the thing. So if you want to stay, you can stay. It's all gonna be in the recording. But though, if you have something going on, you don't have to stay.
Okay. All right. Thank you, Danny.
Yeah. So right now, it just created me two EC2s, these ones. So I'm just gonna rename this one as server. Well, I gotta know first how they are doing. So this one is creating. So let's go check them out. Let's check this one out. Let's go to this IP address. AT. Okay, let's go try the other one also. Okay, so the server B is still working. For some reason, this server A is still having issues. Let me go back to EC2. See their security group configuration. So port 80 is open here. Let me check for this other one. So that's server A. Port 80 also should be open because they are created from the same template. Yeah, it's also open. Yeah, so we're just gonna go with what we have right now because I don't wanna take a lot of time. we can troubleshoot this and see what's the root cause, what is happening in that code that's making the server not to run. But that will take us a lot of time. So we're not gonna do that right now. We're just gonna deal with this one server that we have right now. Okay, so our stack said it's completed. So it's created for us the stack. And if you look at here, the info, the stack, it can give you information about the stack, the event, so now we can see events, and you see the green lights. Anytime you see the green light, which means you are good, and you can see the other stacks, they are in red because they failed. You can look at the resources, what resources you see. It created this server A, server B, and then web server security group. So these are the resources. And then the output, like I told you earlier, the output will display. So this to give you easy, instead of going take that EC2 page, so you can just click on it. Though for some reason, yeah. So let me try the other one. For some reason, whenever I click on that, it doesn't really go to the. Let me click on the second one. Okay, so it's working. So you see, it gives you the opportunity to be able to just have that easy access to the application, to test it, to see if it's working before you can even push it to production. Okay, so this one is, we have our application, one application, even though the other one is not running, that's fine. We're gonna integrate this application with Route 53. So we are gonna go to our Route 53 console. But before we do that, we are gonna create I have a load balancer. So let's integrate this load. We are not gonna recreate the load balancer. I'm just gonna, let me go get this. But you know what? Let's rename these instances so we know the instances that are working well. So this is one that is not working. So let's name that server 1, server A. And then let's rename this as server B. Okay. So then let's go to our, remember we talk about target group. So let's check our target group. So we'll have a target group here. And then let's see. So right now it says unhealthy 0. There's no targets right now. So let's just add a target. Just click on register targets. And then the targets, again, it's just the EC2 instances. So we're gonna, if we select both, it's gonna cry about this server A because it's gonna say it's not. So once you select them and then you click on, I'm gonna cancel so that you see, because I feel like I didn't explain that. So click on register target, and then the target will show up. Select the targets that you want, and then below here, click on include as pending, and then register targets. So it will take some time, and then it's gonna say here, it will say here under this, it will say, you see one target, one healthy. So it already pick up our healthy targets. It say one initializing, so it's gonna bring that one under unhealthy. It's gonna notice that, okay, this server is unhealthy. So we'll see that. If that's the case, if something else is going on, but if it is healthy, it's gonna come under here. Okay, so let's look at the load balancer. So that's how do you create this target? Let me explain that. So if you go back here, all I did was you create target group. So this is under the EC2 instance page. And then creating under this page, just select instances. So you have multiple options here. If you want to use IP address, then you can use IP address. If you want to use lambda function, you can use lambda function. If you want to use this target for a load balancer, then you can use load balancer. But we want to use instances. And then you can give it a name. So I would say demo 2. And then the protocol, leave it as port 80. And then leave it as IPv4. And then the VPC, just choose a VPC. So I'm using the default one, so I'll leave it at default. and then HTTP 1, and then HTTP. So here you can also select HTTPS if you want to. And then health check, you can just put here index.html, or you can leave it blank. Under advanced configuration, just leave this as default. The unhealthy threshold, this is like the number of consecutive health checks success required before considering an unhealthy target. So how many times, how many health checks do you want it to do? I explained this yesterday when we were talking about Route 50. So right now we say 5. He has to do 5 health checks. So you can have up to from 2 to 10. So in the exam, they will ask you which range. So it's from 2 to 10. So by default, it says 5. I didn't select that, I said 5. So that's fine, I'm cool with that. Unhealthy, it will do twice, and then it can declare it to be unhealthy. Timeout is 5 seconds by default, but you can go up to 120 seconds. And then retrieval is 30 seconds. The approximate amount of time between health check and individual targets, that's 30 seconds. And then success code is 200. If everything is successful, you see a 200 success code respond. If it's not successful, you see probably a 504 of, yeah, something like that. And then you can put a tag, and then you click on create. Next. And here you can also select you can select the target just like we did for the other ones. And then you say include as spending, and then create targets. So once you do that, you see it say unused, and then it's gonna transition to initial, and then it's gonna go, if it is healthy, it's go to healthy. If it's not healthy, then it will go to unhealthy. If it is deleting, then it will say draining. So I'm gonna go back. So we have 2 targets right now. Let me look at that other target. So that's let's see this first one. Yeah, so you see one unhealthy and then one healthy. So it detected our target that it was unhealthy, this one. So the health check did not pass. No. Yep. So we have our target, and let's look at our load balancer. So this is the load balancer. So the load balancer, I explain what it is. So I have a load balancer here, and that load balancer, I set it to that target group. I set it to that target group. Actually, I'm going to change some configuration. So this is a protocol, but this target group has rules. So I'm going to change a rule here. I'm going to delete something here. Right now, this rule, the way it is, I'm going to edit this default rule. Edit conditions. Conditions. Edit actions. All right, so I'm just gonna leave it like that. The target, the load balancer. But the load balancer, like I explained earlier, it works with the listener. So with this load balancer right now, if we go to this load balancer, if we paste that load balancer here, so it takes us to access deny. it took us to access deny, because I have a rule that will say this one. But what if, so so right now it's access denied. I have SSL certificate, so it's saying access denied, and this is not secure. What we want to do, we want to secure this application. We want to secure this, right? So we are going to go back to this EC2. So it has, if you look at the listener here, so it has an SSL certificate, which I've already configured. And that SSL certificate should make it to be protected online. It should make this load balancer to be, the URL to be protected online. So let's take a look. So let me look at this default one. That's just gonna take me to the EC2 again. I'm gonna delete that rule. So now let me refresh it. Yeah, it's still sticking. Yeah. So come back here.
Hey, Daniel, sorry, I am off.
Okay.
Yeah, talk to you later today.
All right, sounds good.
Okay, cheers, sir.
Yeah. And so I refresh it. Let me go put it back. Yep, so it's still going to, because it has some stickiness. So what I'm gonna do is gonna go back to this load balancer. Let's go inside this load balancer. Action. So let's create a new load balancer as part of the demo. So we're gonna create a new load balancer. Just click on create load balancer, and then again, as I explained earlier, there are three types. You have application load balancer, network load balancer, and gateway load balancer. And then it tells you like what's for each, when do you use that. So you use application load balancer when you need flexible features set for your application, HTTP and HTTPS traffic. And then you use network load balancer when you need ultra high performance. So for high workload, you want to use like this network load balancer. TLS, which is transport layer secure socket. So that's what we are going to configure next. And then you have gateway load balancer when you need to deploy and manage a fleet of third-party virtual applications. So if you want to deploy like anything from Google or from YouTube, or you want to use this one. So this is what we're going to use, application load balancer, and we're going to give it a name. We're going to call it demo 2. And then we're gonna say internet facing. You can say internet facing if it is just within your application. So we want to do internet facing, leave IPv4, and then leave the security group, and then just select all this this availability zone. Just select all. Yep. And then the security group. Let me see. Let me see what this other load balancer, what security group is it using? Did I use the default one? So I use the default one. So I'm just going to use the default one. I'll leave that as it is. And so this is the listener. This is where you configure the listener. So it's port 80. And then we're going to leave the demo, demo 2 target. And then we're going to, I want to add another listener. I want to add HTTPS. I'm going to add HTTPS, and then I'm going to choose a certificate. Yeah, that one. And then I will select a certificate. Not that one. So I will select from ACM. So I'll select, as I have a certificate here. I'll show you like how to create that certificate. So I'll leave everything as default, and then I'll go next. Okay. So it's done. So we have our rule here. So if we go back to load balancer, and we look at our load balancer 2, so we have this URL. Let's see if it's working. So it was, the old one is working because it's still showing this access denied. That means it's working. Let's see if this other one, but I'll take a look at this old.
Mr. Suarez, sorry, I have a question.
Yes.
Aren't we supposed to like put the websites we want to load balancer to like
Yeah, I already did that.
Okay, okay. And it's
yeah, it's in the target group.
In the tag, okay.
Yeah, so I have to, like this website that you are seeing, welcome server B. It's in one of the instances. One of the instances not running, it's not running okay, but we are gonna use this one. So yeah.
Okay.
Yeah, you just came in. I think you just came in after that part.
All right. Great.
All right. So where was I? Okay, so we choose not this demo 1, we choose demo 2, and then just choose this DNS. Let's go try it out. So if everything works well, our certificate should, our application, we should see our application with a secured stuff. So which means like right now this is not working right now. So let's check it out. Yeah. Oh, it's still provisioning. Yeah, it's still provisioning. So while this is going on, while this is provisioning, let's go to Route 53. Route 53. So again, we talk about how to create Route 53, the domain name, in our last class. So if you have not, if you are not, you've not joined, watch those videos. So in this Route 53, we are going to create a record. So I created some records yesterday, but I deleted them. So we're going to create a new records. So I already connected my certificate. Before we do that, actually, let me show you how do you do the certificate. So if you type, so I have certificate manager here. So if you say CERT, you will see certificate manager. So you just select that one or bookmark it. So I already bookmark it here. So you just go to certificate manager. You need a certificate for SSL. That's what the SSL is what gives you the encryption, make your website, the page if you see on the top here, like Amazon, this Amazon page, you see like this. If you click on it, you see a padlock. So that's what provide that. So you see, if you click on that padlock, it will tell you information about what it is. So like the certificate, view certificate, like this Amazon page, this is a certificate they have. You see, RSA. You can look at any website, their certificates. So this is where you create the certificates. Amazon certificates, it allows you to be able to get certificates. So so click on request certificate, and then request a public certificate. So if you want a public one, so you can go next, and then you give. So here you have to put your fully qualified, say fully qualified domain name. So this is fully qualified domain name. Why is it fully qualified? Because you see, I said DTech, and then there is a dot here, .academy. Usually you see .com here. You see .org or .ninja or .whatever. For me, it's .academy. So this is the top level domain name, TL. I already explained this in the previous videos. And then this is the subdomain name. So when you put the subdomain name, including the dot, then it becomes a fully qualified domain name. So you have to put this here for you to get a certificate. Once you do this, you leave this as it is, and then just click on request. Just click on request. So I already have a certificate. So it's gonna say pending, right? So when it says pending, it wants you to verify, because you use DNS verification. So it wants you to verify that you are who you say you are, or you are the owner of this domain. So right now I see I have one certificate here. So to verify, just click on view certificate. So you can see I have one certificate that's here, but you can to get like what I have already gotten, like this cloud skill, this dtech.academy, it says successful. This other request, if I want to get another certificate, I just need to click on create record in Route 53. So once you click on, let me see, I'm gonna do that. So you click on create record in Route 53.
Mr. Suarez.
Yes.
What's the difference between you creating a certificate and what you did in I think you called it light sale last week?
Oh, it's totally different. So light sale is just like it's a way of like deploying a website, so it deploys like a website for it's just like an EC2 instance, right? It's an EC2 instance that you can deploy your application or your web application on it, or you can do anything with it, just like we are doing things with EC2.
Okay.
And then Route 53, what we are doing with this certificate, this is just like, if you look at here on this top corner, on this AWS, where you say US-East-1 console. So you look and see, usually it will have a padlock here. If you look at other websites, they have a lock.
Yes.
So you see like this lock here. So this is the SSL, and this is how you go about doing it in AWS. Okay.
So it's to make the website secure.
Yeah, it's for security in transit online. Like when in transit means whenever you are sending information, data through the internet. Okay. So whenever someone is gonna come access your information, let's say they download anything or they put in anything, it has to be secure. In fact, you have to meet some compliance, the GDP, the compliance for that. Okay.
Yep.
All right. So certification, I'm not gonna create it. I'm just gonna cancel. I'll cancel everything. I'm not gonna create it, okay? Because I already have a certificate. So I'm not gonna create that certificate. I'm just gonna go back. So we're looking at the load balancing was still provisioning. Let's see if it has finished. Okay, so it says active. Let's try to see it again. If it is still not working. Okay, so it still did not work. But let's try to do some other things. So if we go in there, let's go to Route 53. So in Route 53, we are going to create a record. So to create a record, just click on Create Records, and it's going to be a simple record. So leave simple record. You can choose anyone here, but we're going to create a simple record. And then we're going to go next. And then you are going to go define simple record. And then here you can put, I'm going to put a subdomain, www. That's subdomain. So this is going to look like www.dtech.academy. So if you see that those websites, this is what they do. So we're going to leave this as a record. And then I'm going to choose here application load balancer. Application load balancer. You must have your load balancer before you do this. So that load balancer, I think it's in North Virginia. It has to be in the same region as your load balancer. I think it's in North Virginia. Then you have to choose the load balancer. So right now I have two load balancer. Oh my gosh. I don't even know which one is. I don't know which one is which. I guess I'll just go check. Not Virginia. So I have this load balancer here. Why is this saying? Why is it giving me two demos? Oh, demo 2 is this one. And then I'll just say define load balancer and then select that and then create Route 53. So another record has been created. So remember these two records, the NS record and then the SOA record, which is start of authority. These two records are by default created for you whenever you create Route 53. If you are creating a website, if someone is creating a website for you, I explained this earlier, yesterday, this is, they will ask you to modify this one. This is why they will ask you to modify. So the record that we've created is this one. So if we select this and then get this one, it's probably also not going to work because the load balancer is not working. What's going on? Okay, so it's working. So you see, traffic is from server B. The thing that is not working is the certificate is not working because we are still saying here it's not secure. So the certificate for some reason is not working. So let's go back to the load balancer. So let's click on this. Certificates. So we'll have our certificate rule. Let me see here. Okay, so let's action. Edit action. Think. And then let's say forward target group. Forward to target group 2. Yes. Redirect URL to. So let's redirect this URL to https 443. https 443. Yeah. So let's redirect that to and then yeah, we have our certificates here. Let's click on save. And to prevent a continuous loop, you must change at least one value to define. Which value? Oh, use OpenID Connect. I don't know what's let's try this. Let's see if this one is gonna work. If it doesn't work, then we can come again and okay, so the domain is working, but the SSL is still having some issues working. What I'm gonna do is I'm not gonna keep you guys here for long. I gotta go to church myself, but I will create a short video on this to see it in action, and then I will post that video later. Yeah, so the SSL still is not taking effect. So I'm gonna stop here. So we look at Route 53, we look at certificate manager, we look at a lot of stuff today. So next week we're gonna start with Linux. We're gonna look at Linux, the architecture of Linux, and that's gonna be just a high level discussion on Linux. So we're gonna end here today, guys. Thank you guys for staying